All right, so we left off here talking about storm surges. So as I was saying, a storm surge is really a slow rise in the water. It's not going to be an advancing wall like you see in the movies. And most of the times, the damage that comes from the storm surge is going to come from the superimposing storm waves on top of it. And those are due to the wind, right? So these superimposing storm waves on top of the slowly rising water are going to cause erosion of beaches, islands, roads, whatever they come in contact with. It could be houses, it could be trees, whatever comes in contact with them. So all of these eroded material that comes from the wave action is going to be carried inland as the storm or as the rise of the level of the water increases. So you're going to see this overwash, which is going to be basically material that has been eroded and has been later on deposited further inland. So assume that the say the sands that were make up the beach itself are eroded and then are carried within this water that is rising and then are deposited further into a neighborhood. Once the hurricane passes and the sands are left there, they're going to be overwashed. They're just going to be material that has been eroded and has been carried inland. So much of this overwash material is deposited at the end of the channels, and that is going to be called the washover channel. So the washover channel is this overwash material deposited towards the end of where the overall level and the sea level and the sea water rose to, and it's going to basically tell you which were the channels that the water took as it was rising and as it was lowering back down. So it's going to leave a bunch of material to the sides of where the channel took as it was rising and as it was lowering. So it's called washover channels. So you're going to see both of those terms, overwash and washover channels, in your quiz. So if you have questions about them, make sure that you go over them beforehand. A second effect from these cyclones that I wanted to talk about was the high winds that come along with them. So although they create less damage overall than storm surges, it is a little bit more obvious damage, more apparent. And it also tends to affect larger areas, right? Because storm surges only happen where, there's coastline, there is access to the sea, whether wind damage goes wherever the hurricane actually goes. So if the hurricane travels inland, however many miles, then you're also going to get wind effects from it. So the highest winds occur again at the eye wall, which is that next to most center layer of clouds, which is also important to know, which is also why it is important to know, where exactly a hurricane will make landfall. So if a hurricane makes landfall, let's say 100 miles from Houston, then it is very likely that the wind speeds are going to still affect Houston and be about 119 kilometers per hour if that is a Category 1 hurricane, right? Because again, it is 160 kilometers in diameter that those wind speeds have to be. However, if the hurricane makes landfall 300 kilometers from Houston, then the wind speeds that are going to affect the city of Houston are not going to be nearly as extreme because, again, of that categorization of the wind speeds for a hurricane, for example. So highest sustained wind speed that have been measured was actually 320 kilometers per hour, which is just crazy. So if we go back real fast to the overall categories, let's see. So this is in miles per hour, but if we transform this category 5 of 155 miles per hour to kilometers, that would put kilometers about 220, if I'm not wrong, 230 kilometers per hour. So again, the highest ones recorded were 320 kilometers per hour. And this happened in the 1935 Labor Day hurricane. So due to this hurricane, a train was actually completely derailed And this train was carrying World War I veterans that were working in the Florida Keys. So it was completely derailed, blown off the rails, and also during this same hurricane, 423 people that were, in the coast at that time were sandblasted by the sand that was, in the beach and carried by the winds. And as they were sandblasted, they all died because the wind speeds were so high, and with sand grains hitting them, they died due to that major high speed winds, which is pretty sad, and that can happen pretty often. So typically, once the hurricanes make landfall, the wind speed actually reduces exponentially. So if the wind speed, the wind speed will be reduced in half within about 7 hours after the storm crosses the coastline. So say a hurricane makes landfall in Florida and it's traveling in a forward manner about 20 kilometers per hour. Then about 140 kilometers after it reached the coastline, the wind speed will have been already half the speeds that they had been before. And then again, those are the inner speeds of the hurricane, not the forward speed of it. Okay? All right. Okay. However, some of the hurricanes don't actually reduce their wind speeds themselves. Most of them do, but some of them don't. And at times they may even increase in speed depending on the weather conditions within the area where they hit. So by increasing their speed and going further inland, they might actually become extratropical cyclones and kind of feed off by a different process. Okay, so the highest wind speeds that were recorded in the U.S. were actually from an extratropical cyclone, not from a tropical one, and they were 372 kilometers per hour. This happened in Mount Washington in New Hampshire's White Mountains, and this was in 1934. So actually, Mount Washington experiences a lot of hurricane strength winds, about half of the days of the, or not half, a third of the days of the year, because of the topography and the overall location where it's situated. So it sees very high wind speeds pretty much a third of the days every single year. And again, holding the record for the highest wind speeds in the US recorded at 372 kilometers per hour. So the high winds from this extratropical cyclones tend to be greater than from tropical cyclones, and they cause destruction in the western US as well. An example for this is the Big Bull in 1962, which had winds of 260 and 290 kilometers per hour along the Washington and the Oregon coast, respectively. So again, Washington had 260 kilometers per hour, Oregon 290 kilometers per hour. So pretty high wind speeds for sure. So also these extratropical cyclones tend to cause blizzards and tornadoes in the central North America, and also deadly windstorms in the Great Lakes. Some of the wind speeds in the lakes have actually been recorded to be over 160 kilometers per hour within the lake, and causing waves of up to 11 meters. So 11 meters is a lot, and that can sink major ships, and it has done so before. So major player within cyclones is the high winds. The last effect from cyclones that I want to talk about are heavy rains. So on average, a hurricane will basically give you 1 trillion gallons of rainwater each day that it lives. So 1 trillion gallons of water, to kind of put it into perspective, is nearly 3 times the amount of fresh water that is consumed by the US each year. So one hurricane gives you basically 3 years of fresh water, which is what we would use in the US. So a lot of water. So usually these tropical storms and depressions may bring close to or just as much water as hurricanes. Definitely tropical storms would. maybe not so much tropical depressions, but tropical storms would definitely come close to giving you as much rain, perhaps even more so, like Superstorm Sandy did, for example. So what this heavy rains cause is definitely extensive flooding, and that may be worse as the storm gets further inland, being that those areas are not used to seeing as much water, or perhaps it may be worse because the hurricane itself is encountering some topography, so it's, higher altitudes that have more cloud cover within the hurricane are actually encountering some barriers, which is going to be this topography, and is going to cause precipitation to occur more greatly than at lower elevations. So, in fact, some of the heaviest rainfall events from hurricanes and tropical storms happen when they pass mountainous islands. So, I forget where it is, but it's somewhere in the Pacific. Your book has it specifically. I think it's in like near Indonesia or so, but somewhere in there, they say that this island has seen rainfall events of I think it was like 12 meters a day or something ridiculous like that of rainfall that has fallen due to the passing of this hurricanes and tropical storms. So obviously, by this amount of water, and by the locations that receive it that are not used to receiving this amount of water, it takes many days to recover from this extensive rains and extensive flooding that occurs due to that. So it's also one of the major effects from these hurricanes and tropical storms and cyclones overall. So now we move on to the linkages between cyclones and other natural hazards. So we can see how cyclones may be related to coastal erosion, more particularly so tropical cyclones, right? When you have tropical cyclones and they make landfall, usually you're going to have this gigantic wind speeds, this storm surges, this heavy rain, that overall wind and water are great erosive mechanisms, right? So you're going to get a lot of coastal erosion. That's the first one. Another link is going to be with flooding. So as we just saw from the heavy rains, you're going to get major flooding occurring. And you're also going to get flooding occurring due to the storm surges, right? You're going to get mass wasting events, as you're seeing here in the picture on the right. So this, I think, happened in Costa Rica, and this, I think, was a cause of a tropical storm. So when you have a lot of rain, that rain is going to infiltrate to a certain degree into the soils, but the soils may be too saturated to, intake more water, so they may completely lose their strength, and they may be too heavy, so they may completely just give in and cause this mass wasting events as you're seeing it in the picture, for example. They're also going to be related to other severe weather processes such as tornadoes, thunderstorms, snowstorms, and blizzards. And we saw all of these last week, and we touched base on them this week as well throughout the last few slides, so that shouldn't be too much of a surprise for you. They're also directly related to climate change. So if you think about climate change driving this process, so or at least tropical storms for sure. It's an easier way to think about it. So tropical storms again form when you have warm waters, warm seawater and warm moist air in the tropics. If you have overall more area that has this warm waters and warm moist air, which is what we're seeing with the overall warming of our planet, then it is more likely for you to get more cyclones, at least initially developing, right? So also because of these cyclones that are traveling northwards, and as we saw from, let me find it, from this image over here, the outflow from those hurricanes is going to drive some of the heat into the polar regions. It's overall going to be warming the planet also a little bit more. So that's another way in which we can see the direct relationship from cyclones to climate change as well. So it's a two-way street, if you would.